Welcome to the Green Chemistry Promises podcast series. Welcome, everyone, to the Green Chemistry Promises podcast series. And today is the first episode for the series where we're going to speak about green chemistry in the real world beyond lab space. Our guest speaker is Professor John Werner, who is one of the co-founders and the fathers of green chemistry. He's the CEO and CTO at Technology Greenhouse. I'll be your moderator, Engineer Omar Al Saleh from the RSS, and I'm also the project lead for this project, which the podcast is being run under. It's the Global Green Chem program that is running throughout 6 countries. And here in Jordan, we're actively implementing it and translating it to action. So without further ado, I want to give Professor John to introduce himself, and then we can start with this great ride and roller coaster.
Hello, thank you very much. It's my honor to be the first guest on this podcast. My name is John Warner, and I am mostly an entrepreneur inventor. I run a research lab called Technology Greenhouse in the Boston area in the United States. It's about a 20-person research lab where we work with industry to invent solutions for their problems, and then we create new technologies and spin out new companies. Also have my I have a couple academic positions around the world as well, but mostly I'm an inventor in creating new technologies.
Thank you, John. I'm really happy to have you. So I think with your background and perspective, we're going to really get our eyesight beyond the lab space. How did chemistry evolve? As we know, it's usually looked at as a dirty work, as something that is not really welcomed by people, something that's hazardous, that's against health. So how did chemistry evolve and became an integral part of our life and economy?
Well, the thing is we live in a very polarized world, as you know, and that, historically, chemistry has been such an amazing part of civilization. It has, cured sick people, it has fed hungry people, it has created housing and clothing, and we just have had so many amazing advances with chemistry that have been thrilling. And we got to never forget how important chemistry has been to all of humanity, preventing human suffering and creating benefits for society. Unfortunately, it wasn't until really the middle of the 20th century, 1960s, about that we started to realize that there was negative impacts on chemistry, to how it impacts humans and the environment. But the way we teach chemistry was already established. So we already were established how we were teaching people in chemistry, chemical engineering, and material science before the environmental understanding happened. So changing that curriculum has been difficult, but it's not an epic battle of good and evil. It's just something that we chemists never really embraced as part of our responsibility.
Yeah. So again, chemophobia is something that's really common.
Yes,
So can we say that green chemistry is somehow the way out for this to really tackle this phobia?
I hope so. Now, I would feel that if you say anything about biology, people go, oh, trees, plants, and everyone gets all very happy. You say something about chemistry, it's, oh. I feel that fear of chemistry, that chemophobia, is kind of the way we've evolved how we teach it. And it's just how our society, we chemists, we material scientists are not doing as good of a job as people in biology in explaining the benefits, in that every aspect of biology has chemistry as its foundation. So how can chemistry be bad and biology be good when biology is built upon chemistry? It's more of a communication issue than a reality. And I do hope that green chemistry helps get the world better aligned.
So again, we spoke about its evolution,
Mhm.
and how the perspective of chemophobia has really grown on the
Mhm.
surface. But again, now there is chemistry revolution, which is green chemistry, with it being inspired from nature, and doing the right benign design for things to happen right, and for our economy to be reshuffled.
So, if you look at how chemists are trained, if you look at the classes and the courses that chemists take at university, they're the ones that when they graduate, or maybe while they're students, they invent amazing things. Let's say that I want to make a red dye. I can point to the courses that I had at university that taught me about what makes the color red. All right, so I can design a molecule that is red. If I want it to stick to a fabric, I can point to the courses that taught me how materials stick together. If I want it not to oxidize or fade in the air, I can point to the courses that taught me that. But if I don't want it to be a carcinogen, if I want it to biodegrade in the environment, if I didn't have courses that taught me those mechanisms, how can I teach it? So as we change the field of chemistry to have people learn not only the mechanisms of what makes a molecule or material good for society, but also the mechanisms of what makes it bad so they don't do it. Now we can have it both. We can have products that work better than what we have today, cost better than what we have today, but don't cause negative impacts on health and the environment.
So you said it costs better than we have today, but again,
Yes.
we spoke about chemophobia, and there is greenophobia, circular economy, the global green economy transition, and so many global trends and buzzwords are out there that
Hmm.
really scares so many businessmen in the business sphere, or even
Hmm.
industrialists, because they see that this is either impractical or expensive. These two words, expensive and impractical. So if you could really get us a more deeper side of your work, of other
Hmm.
brand alternatives that are green but yet competitive in the market.
So we got to remember that in the early days of environmentalism, 30 years ago, maybe 40 years ago, companies felt, oh my goodness, we must have sustainable, safe, non-toxic, good products. And they quickly came to market, but their attitude was, you should use this product because you're a good person. And if you're a good person, you will use this product. Yes, it doesn't work as well. And yes, it's a little bit more expensive. But if you're a good person, you will use it. And of course, that people did not accept that, as they shouldn't. No one wants a cleaner that doesn't clean just
Yeah.
because it's more sustainable. And if it's too expensive, not only is it difficult to succeed in the market, but now that also creates economic disparities on who can be safe and who can't be safe. But that was 20, 30 years ago. But people still have this memory of those early examples, and that has really ingrained inside their psyche that, oh, green must not work and must be too expensive. But there's, in fact, for the last 20 years, the field of green chemistry has shown time and time and time again that you can have products that work better and cost better. But the bad stories, just for whatever reason, linger in people's minds. But there is right now there is no reason why a product that is better for human health and the environment must not work as well or must be more expensive. It is a matter of the inventor having the skills to invent it. And there are plenty of examples.
Before we delve into some examples, do you think that one of the reasons is maybe lack of collaboration? Like we know that we're not all scientists, so sometimes a scientist would think, okay, I could come up with the product, I would come up with the
Hmm.
innovation, the ideation side, but then
Hmm.
commercialization is kind of beyond me. So maybe that's because of lack of having a good team that's in place for his business model.
Yes, we need collaboration in how we communicate. Okay, because the thing is that if I make a new product that has a new property, now it is a neon color or something like that. I can say to people, oh, look at this new neon color. You couldn't have this before. And they, oh, wow, that's really interesting. Or I make a new fabric that is more stretchy. And I say, look at this fabric is more stretchy. And they go, oh, that's really good. But if I say my product now is not toxic, my product doesn't hurt the environment, the people didn't realize before it didn't hurt the environment. So it's not something that they expected as something new. We have to tell them what we were selling you yesterday was not good. And today there's, and that's a very difficult thing without collaboration, without people working together to handle this. It's very different because the bad aspects were invisible to people in the past. So how do you first you have to tell people what you have today is bad, and this is it's a very different mindset.
So what examples do you have of certain alternatives that have been commercialized?
So,
They're,
so
they're
there
proven in the
are
market.
hundreds of examples. In the United States, there is the EPA has the Green Chemistry Challenge Award that is awarded over 140 awards to companies that have products on the market. In the UK, there is the Crystal Faraday Award that has awarded dozens of things. So if you look around in other countries, and in Taiwan, there is a green chemistry program. In India, there's a green chemistry program. In Australia, there are so many countries that are celebrating companies that have created products on the market. They span every aspect of products that we've come to need in our society.
I remember you were part of one of the projects, or you actually own the company, which is
Uh,
the hair dye, and there is
yeah.
another
Yeah.
the road pavement where they've used different.
Yes, yes. So,
Yeah.
so here's a few examples, okay? Using green chemistry, my little tiny group, it's a very small group, under 20 people and not massive funding. We have started a pharmaceutical company that has an ALS drug in phase 3 clinical trials. We have a hair color technology called Hairprint that has been on the market direct to consumer for over 10 years. We have an asphalt paving technology where when you repave a road, because the sun and the air oxidize the surface and it cracks an asphalt road. Usually you dig it up, you buy new asphalt, new aggregate, and you repave it. This allows you to use all of the material in the road. It adds a catalyst and allows you to reprocess the road. We have a photovoltaic technology in manufacturing that allows you to any indoor electronic device. It keeps the battery charged. It doesn't power the device, but you never have to actively charge it because ambient photons indoor constantly charge it. A water harvesting technology, a flow reactor, photo flow reactor, and it goes on and on. So there are several examples of successful technologies that work better than incumbent technology and have the appropriate cost, and people want them for those reasons alone. And then you say, and oh, by the way, it happens to be non-toxic and doesn't hurt the environment. That, in my opinion, is the appropriate way to be doing this.
So, okay, great. So we have a lot of so-called green alternatives. But
Mhm.
again, if there's no clear metrics to judge if it's green or not. So what
Mhm.
about greenwashing? How do you see this is a global actually challenge that we're facing in
Yes.
various topics. So when it comes to green
Yeah.
chemistry, how would you
Mhm.
tackle greenwashing and really define that this product
Mhm.
is green and worth
Yes.
buying as an alternative?
So first we have to accept that the enemy of the excellent is the perfect, and there will never be a perfect product. And so if I have a product if there's a product on the market today that, let's say, causes cancer. And I invent something or somebody invents something that reduces that cancer potential by 50%. So now it's twice as good. You could either say, wait a minute, it still is a carcinogen. It's not good enough. Or you could say, oh, it's now twice as good as what's on the market. If we say it's not good enough, then what we're doing is we're allowing the current product to stay on the market. And so we have to look not at how close to ideal a product is, but how much better it is from that which is already on the market. Because there's a lot of people want perfection. Of course, why wouldn't people want perfection? But perfection doesn't exist. And so we need to realize that the way science works, if you improve the toxicity and then someone else makes it biodegradable, then someone else says, oh, I'm going to take those ideas and I'm going to reduce the energy use. Then someone else says, oh, I'm going to reduce the water use. We need to be patient. If every time somebody says, I've made a benefit, and everyone just looks at why it's not good enough, then what incentive do people have to invent something better? We'll be stuck with the things that we have today. The economy has to go. So there's two types of greenwashing. There's greenwashing that is the lie. That's when somebody just lies and says it's non-toxic and it really is toxic. It biodegrades, but it doesn't biodegrade. That we must be very serious and stop people who are misleading. But what we need to be careful is when we find ourselves saying it's not good enough. Okay, because in my opinion, if you look at all the technologies in the world today, we can only improve 10%. 90% of the technologies that need improvement for toxicity, environmental, haven't been invented yet. And so we need to move the ball forward. We need to create these technologies. And if we tell inventors, if you don't invent in sustainability, no problem, everyone will just accept whatever you do. But if you mention sustainability, if you mention toxicity, we're going to make your life that much more difficult, then people won't bother. And so we need to realize, again, it has to do with this collaboration of people. We are human beings and we need to respond to those human beings just as at the inventors and help them as much as possible.
Okay, as a professor, I mean, you
Yeah.
deal a lot with students in the lab
Yeah.
space. How do you
Mhm.
actually bridge them to the real world? Because we know that usually maybe
Yeah.
academia sphere is more ambitious, more,
Mhm.
as they say, innovative. So they
Mhm.
might really come up with stuff that are really beneficial, but then scaling up is the challenge. So what
Yes.
do you do in terms of these foreseeable efforts?
This is a very important point. Okay. I think that teaching is the most sacred of professions, that educators teaching the next generation, that is a very difficult job and it's very important. I'm worried that over the last 10, 20 years, we've kind of changed the way we evaluate teaching. A professor, when I'm very old, when I was a student, you know, the thought that to get a PhD, you must have three publications would have been laughable. People would have said, how can you measure research by number of publications? But somehow over the last couple decades, we have switched from looking at what the research is to how many papers someone publishes. And so what that does is someone is motivated to get as many papers out. So if you're in chemistry, you do methyl, you do ethyl, you do propyl, we'll get three papers. And so what's happened is over the last 20 years, to get publications in journals, people just want as many as possible. So they don't want to do all the, not just the coming up with the fundamental mechanism, but then how do you improve it? So what we find is people will have a new material that has great properties, but then you find out they made 22 milligrams on a microscope slide and it cost 50,000 euros, $50,000 to make. That's great if you want a publication in a journal, but that's not going to help the real world. And so, because professors are under a great deal of pressure to publish, 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 they don't have the time anymore and the luxury to think of how do you go from the fundamental concept to the practical. And at the same time, industry over the last 20 years has looked at their budgets and said, we will outsource R&D. We will just focus on development. And so now what we had before was academia going into development, industry going into research, and there was a good overlap. Now, in the 21st century, unfortunately, what we have is a gap that there's fundamental work and there's industry and there's this gap. And I think entrepreneurship is where that gap has to be filled. It's not that everybody should become an entrepreneur, but academia needs to understand how in entrepreneurship works. Industry needs to know how to collaborate with entrepreneurs so that we can do this. And if organizations, if regions, if people find out how to make that three-step academia, entrepreneur, industry work, look out.
And that's actually one of the challenges that we're facing in the transition,
Yes.
any transition. And since
Hmm.
green chemistry contributes to circular economy and the green economy transition that we're all longing for as different nations. Um, so again, bridging academia with the business sphere.
Yeah.
So if entrepreneurs are going to do it, they don't have to be scientists. So here,
Hmm.
just to re-emphasize on the fact that there should be a good collaborative work, sectorial, and also
Yeah.
multi-stakeholder involvement to actually get this transition happening.
Absolutely. So inventing, being in the lab and understanding chemistry and engineering is very difficult. To say, oh, and you also must learn business, that's not what I'm saying. I'm saying that the people in business, that's very difficult. Learning finance and marketing is, these two groups need to better collaborate. They need to work better together. It's not that people should become scientists, engineers, marketing, business. One person can't do all this. We need to have collaborations, people who work together to share these things and have and understand how to communicate. And it ends up at the end of the day, in my opinion, it's all about communication. The language of science and engineering is very different than the language of marketing and business. If that were not true, there'd be no chemophobia. So the fact that we have chemophobia is proof that the communication between science and engineering and marketing and business isn't very good. We must fix that.
But do you think that the pace of our economy in terms of production, the industry works, is not really in line with the pace of academia work? So that's maybe one of the reasons of the gap, the huge gap
Yes.
between both spheres.
Yes, I think again, it's very, very difficult. And I think there needs to be a little bit of give and take from both sides. I wouldn't say academia must change alone, but industry must change, academia must change, and re-examine that collaboration. And so I was a full tenured professor of chemistry and a full tenured professor of plastics engineering in the US. I resigned my academic position. I was very sad because I loved being a professor, but I felt if I'm going to be in the lab inventing things, you know, then students, I wouldn't be able to give my full-time attention to students. All right. And students deserve full-time professors. And so I step in, but I have a lot of students working as interns coming in and collaborating in industry. So I try to see how do we bridge this thing so that we have the students aren't compromising their education, but are learning not only how to publish a paper in a journal, but how to work on a team in industry, how to understand setting goals that are fast and sometimes ambiguous. And we need to help train the scientists to understand how to work in a business environment. We need to train industry on how to adapt to the academic environment.
So again, everyone speaks about incentives, and the
Yeah.
government has a huge role here. So
Hmm.
lack of leaders of change. So
Yeah.
what do you say about this? I don't know.
If
Is the
yeah.
incentive packages, is the government really in line with the interest of the industry
Yeah.
along with the academia and of course the well-being of society?
Well, from my perspective, it come in and obviously there's so much in government that's complicated. In my past, I only see a little bit of that, so I would feel presumptuous to say government should do because my experience is limited. But from my perspective, everything, right now, when I look at government policies, they talk about alternatives assessment, substitutions. We must force industry to change to do this. And I think once people realize they haven't been invented yet, that this is not a crisis of desire. Who wouldn't want a product that is non-toxic and doesn't hurt the environment if it works better and costs better? So we need to realize that this is a crisis of ability, not desire. And how can policy help with that? Well, we need to have training in industry and in academia. So industry needs to help train academia on what it means to work in business, but business needs to be trained by academia how to be more sustainable, how to create non-toxic, and we need to be willing to have that crossover.
Well, we hope that this works. It's actually a long, long journey and a
Yes.
long transition, and transition does take time. I want to ask you this question first. What inspired you actually to go into green chemistry? And also, I know you don't really look at money. It's more of a
Mhm.
message that you want to convey to people
Mhm.
to actually change for the better. But is do you see after being part of this both spheres, I would say the
Mhm.
academia and the entrepreneur world. Um, do you see actually GC, green chemistry, and any green alternatives being profitable? So now, to be more specific, in the products that you're
Mhm.
having in your hand, do
Mhm.
they actually profit enough from it? Even though I know you don't like to speak about money, but it's good
Mhm.
to have the business mindset somehow in line with it.
Well, yeah, greenwashing. We also have to think about profit washing. Okay. Now, what does it mean to be profitable? Are we talking about having people employed in a company, making enough money to pay for homes, send their children to university, buy a couple clothes, maybe go on nice vacations? Is that profitable? Or is it an investor getting a 20x, 100x return on the investment? So just like greenwashing, sometimes we go profit washing that what is enough profit? Okay, now we need investors to succeed. That is the engine that finances industries. I'm not suggesting that that's not an appropriate thing, but sometimes just having a company stay in business and not go in business is something to celebrate as well. And a lot of times, shifting to a more sustainable technology maybe doesn't make the massive success, but it keeps people employed, keeps jobs, and helps local economies. And so, from my perspective, if there is a region that has 12 people who are unemployed, and now they have a job making some product, and they're not exposed to toxic materials, and they're not hurting the environment. That is a success. If we do that over and over again, that's what changes the world. But sometimes we aim so high. Oh, if it's not the next Apple iPhone, then it's not a success. Well, there's a lot in the world that's a lot smaller than that that save people's lives, that save environments, and we need to readjust what we mean by profitable. Okay, and so you asked what got me into this. I am going to share with you something very personal because I think it's important for people to understand this. Right? When I was 27 years old, it's probably one of the most successful chemists on the planet. At 27 years old, I had already about 50 patents, about 50 publications. I had awards all over the place. Celebrity Magazine had a story. I'm on the cover of that. I was very, very successful. I'm very proud of myself. I am a great chemist. Wow, look at me. And disaster happened, and I lost my 2-year-old son to a birth defect. And lying in bed the night of my son's funeral, I'm asking myself, did something I touch in the lab cause this? Did something, that I maybe got an award for behind this? And I realized, how can I consider myself such an amazing chemist if I don't know the answer to that question? So it drove me crazy. And then I realized this isn't an epic battle of good and evil. It's just absent from what it means to be a chemist. I never had any courses, any training, maybe a little bit about if you're working with a known molecule, how do you look up what is known about that? But if you're inventing something new, there's no information on how do you predict whether what your new thing is going to be. So although it was a horrible story, I really felt optimistic that this can change the world if we change the way we teach chemistry. So Paul Anastas, my dear friend that I grew up with as a childhood friend working, in the EPA in the United States, and we wrote this book, Green Chemistry Theory and Practice. But my approach is not to be someone talking about all the bad stories. But if I could, I have 360 patents. I have licensed over 40 technologies to multinationals. I've created 12 companies that are all successful and growing. If people can see that even someone like me can, with very little funding, can be successful, maybe that'll motivate people to, well, maybe I got to learn a little bit more about this green chemistry because I feel my success is not in spite of green chemistry, but because of it. Green chemistry accelerates R&D. Green chemistry accelerates manufacturing because many times when someone invents a new technology, it's not for a year or two that someone realizes, wait a minute, there's a regulation that says we can't use that solvent. There is too much energy. We can't do, and then everything falls down. If the inventor, if that first person understands what it means to make a product in the real world and they invent it right the first time, everything is more profitable and faster to market. But if they don't have those skills, all you have is accidents that have to be repaired.
Yeah, yeah, exactly. What would be your final takeaway before we delve into Q&A with the audience?
I I feel that everyone in society, this is not a polarized. If you are someone who's more on the environmental side and you're concerned about the environment and sustainability, green chemistry is the solution. If you're somebody that's worried about economic development, regional economies, and creating jobs, green chemistry is the answer to that. So we need to realize that this isn't one or the other. This is a unique opportunity to create an economy, grow an economy. If everyone was already doing green chemistry, we wouldn't have this as an opportunity. Although I want the world to one day everybody be doing it, we still got a long way to go. So those regions, those people, those organizations that embrace this, we're still at the stage of early adopters. And at a regional level, I feel very strongly this is about economic development and jobs creation if it's done correctly.
Thank you, John, for this inspiration. Thank you for all the information. And again, green chemistry in the real world, it is actually
Mhm.
beyond the lab space if we only intend to do so. So I'll open the floor for Q&A. Please try to be brief. We have 15 minutes to embrace that. We could extend, but 15 minutes is what's provided for the Q&A. So if you have any questions, there's a chat box, or even you can unmute yourself, but keep it brief and to the point.